Alright, so this video is dedicated to Sadie, whose half birthday is today and who decided to not bring treats. Whatever. And to Sydney, who decided not to show up to class today. So. And my daughter, please be a good girl and take your nap today. And don't pee in your diaper. Oh, Tenley. Yeah. Okay, here we go. So, today you want to graph hyperbolas. If you flip to the very back page, this is the section where I give you kind of all the organizing notes about hyperbolas. And hyperbolas are very similar to ellipses, but they just kind of go in the opposite direction, so to speak. So, for example, if you look at this one right here, this is the hyperbola. And it has a vertex, kind of like how parabolas have a vertex. And then you got this other side to it right there. So this is an example of a horizontal hyperbola. It's got a center right there, and then it has these things. Again, they're called asymptotes or asymptotes, whichever way you'd like to describe it. Either way is fine, despite what anybody else says. And that's that. We also have these points on the inside that we use to generate the actual graph. Do you know what those are called? Foci. Yep. So it has a lot of the same characteristics. We add in the asymptotes, but a lot of the stuff is going to be the same. Now you can have horizontal or you can have vertical. Okay? And that's what we need to kind of look through today. So this is the picture you should have in your mind when you're thinking about hyperbolas. You can notice for this next one that goes up and down, and that the vertices again are spread vertically, and the foci are spread vertically as well. Okay. Now, yesterday I was able to take that shoestring, and Scott was able to help me, or 2 days ago, and we were able to draw an ellipse. You can't do that with hyperbola. It doesn't work quite like that. But here's what happens. If you take a cone like this right here and you stack one on top of one another and you slice it, the bottom part gives you one half of the hyperbola and the top part gives you the other half of a hyperbola. And that's how you generate it, okay? That's how you would cut it. The actual definition, which you're not going to have to memorize for the test, is as follows. Hyperbola is the set of all points whose distances from the two foci have a constant difference. That is very, 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 very similar to the definition of an ellipse. How is that different? Yep, instead of difference, what do we have for ellipses? We have sum. Yep, so you remember we had that shoestring, and it had a kind of a constant length to it all the time, and so that length was kind of the sum of those two distances. Well, for hyperbolas, it's a constant difference. So that's going to generate the two types of equations that we have. We have our horizontal, and we have our vertical. And for horizontal, you would have x squared over a squared minus y squared over b squared is equal to 1. How is that different from your equation of ellipses? Subtraction, that's it. Vertical, y squared over a squared minus x squared over b squared is equal to 1. Now, got to be very, very, very careful here as we answer this question. Don't be afraid to give an answer. Every answer is good. What is different between the horizontal and the vertical equations of hyperbolas as you look at them? Say something more. What about the x and the y? Yes, that's the important part, okay? When we were doing ellipses, you could move x and y back and forth, right? Because they were both positive. Like subtraction, can you simply switch these and have the same value? No, subtraction is not commutative, and it's not associative. You can't just move it around however you want. It doesn't work like that. So the important part here is don't focus on the value of A or B. Don't focus on that at all. Focus on what is positive. Here, x is positive. Here, y is positive. Whichever value is positive is the value that determines the direction. Hello, my friend. So, vertices. Okay. In this case, it will be plus or minus a, 0. In this case, it will be 0 plus or minus a. So what we're going to do is we're going to go a units in the positive direction. And we'll go a units in the negative direction. And those are our vertices. That's what we get. If it's vertical, we plot the vertices along the y-axis. And again, all this is assuming that the center is at 0, 0. Yes. Yeah. No. No. Yeah. There's a lot of okay, your question would really be, the question is, I would say that no. I would say that hyperbolas will come up more often in mathematics than ellipses will. Okay? You will see ellipses in Calculus 1 and Calculus 2. The tough thing about ellipses is they're not functions, are they? So we make just a little twist to calculus, because calculus really likes functions, but it can work with stuff that isn't functions. So you don't see a lot of it, but you see a little bit. In terms of application, yes, ellipses, the primary focus would be as you look at astronomy. But hyperbolas, lots of different scenarios. So that we could go on for a long time. Lots of applications for that. Good question. Excellent. Okay, the transverse axis is going to be this guy. Transverse axis is really the distance between the two vertices. Anybody want to guess what the distance between the two vertices is? 2a. After I plot the vertices, what I like to do, and your book doesn't tell you to do this, I just think this is the easiest way. When I first went through this material, I was taking the class on my own, and I had to figure out how to do hyperbolas and ellipses and stuff, and I just needed my own method, and so here's how I started to do it. If I go A units, look at this, A units horizontally, how many units do I go vertically? B. And so I'm going to go B units vertically. And with those 4 points, I'm going to make a box. Now that I have that box, I'm going to use that box to draw my asymptotes. How do you think I use the box to draw the asymptotes? You have to go through the corners or the diagonal of the box. And I just think that helps you keep your work more organized. It helps you generate the appropriate shape. Okay, gotta think through this. This is super important that you connect this to your learning, okay? The asymptotes. Are the asymptotes a point or a line? A line. Are they a vertical line, horizontal line, or neither? Neither. So therefore, they're going to have an equation of like y equals mx plus b. Now, what's the y-intercept for your asymptotes in this situation? 0. So you're going to have an equation of y equals mx. So all we need to know is find the slope, right? Look at the slope. How many units up? How many units over? A. So the equation is y equals b over a times x for one of the asymptotes. What do you think the equation is for the other asymptote? Negative b over a. So that tells us the equation for our asymptotes. That way we could graph them. Let's look at the next one. You would go b units horizontally here. And you would make your box. Now that we have the box, I draw my asymptotes. There we go. Same thing, y equals some number times x. Let's look at the slope. How many units up? How many units over? B. So a over b times x, and it will be plus or minus. Most commonly, when people do their test, they'll just write whatever b over a is, so 5 over 2 or something like that. But it's not a number. It's an equation for a line. You need the y and the x. You need all that in there, okay? And finally, the foci. The foci sit c units from the center. So plus or minus c, 0, and 0 plus or minus c. So that might be one focus point. That might be another one. Do you remember the equation for foci for the ellipse? C squared equals a squared minus b squared. What do you think the equation is for hyperbolas? Plus. Yep. C squared equals a squared plus b squared. So that's what we use to determine C now. Just the Pythagorean theorem, which is the basis for how all conic sections are derived anyways. Last thing I'm going to do is sketch my graph. You start at the vertex, excuse me, and you then travel along the asymptotes. You make a nice gentle curve. Those are two nice shapes. So I told last hour, every day when Kira comes home, I say, Kira, what did you learn in school today? What did you talk about? When your parents ask you that today, you can say, we discussed the asymptotic behavior of hyperbolic functions. And then you have all sorts of stuff to talk about. Okay, there you go. So let's we've got it all down now, right? We got the notes there. Let's try two problems. Two problems, and that's all we do today. So let's do them. Sketch the graph. Find the vertices, foci, length of transverse axis, and the asymptote. So I'm going to start by identifying. They don't ask. Need to put this there. Later, bud. Direction, and we will also say center. I think that those are important to look at first. Then after that, then I look at the vertices and the foci and the length of the transverse axis, asymptotes, and obviously I'm going to need to know A, B, and C. okay. Is that a squared plus b squared equals c squared? I don't know. Because it's a free country and I do what I want. I don't know. Okay. Okay, I caught everybody on this question so far. Direction. Up and down or right and left? Which is it? Okay, so I put this problem here. I put the 25 under the y because that's bigger and that's what you're used to looking for ellipses. But that does not matter for hyperbolas. What matters, C bar? Half birthday girl? You said horizontal. Why? You said horizontal. Yeah. Well, not just where the x and y are, but whether or not x is positive or negative. So x is positive, so it's horizontal. If y was positive, then it would be vertical. I always look to see what value is positive and what value is negative. And I say that because next week on Tuesday, I'm going to give you this. And you're going to have to turn it into either a circle, an ellipse, or a hyperbola or a parabola, and you don't know which one it is. When I look at this, I can tell it's not an ellipse because you have one value positive and one value negative. I can also tell it's not a circle because circles also have just positive values. I can tell it's not a parabola because parabolas don't have both values squared. Hyperbolas have both squared and one that's negative. And I'll teach you how to do that on Tuesday, but we got to make sure that we focus on the fact that which value is positive, which value is negative. That's uber important to your success moving forward. So we know that it goes to the right and to the left. Awesome. What's the center? 0, 0. A, B, and C. In hyperbolas, A is always the first number. Yes, it's 2. B is 5. C, I take A squared plus B squared square root of 29. Yep. Anybody confused how I got A, B, or C? I've got them. Now it's time to go to work. I got to draw my graph. There we go. Got a graph. Vertices. How many units? Which direction? Yep. If you look here, right here, okay? X. There's a 4 underneath it. So I go 2 units in the X direction. I go 5 units in the Y direction. Okay? Tells you everything you need to know right there. 2 units in X, 5 units in Y. So I'm going to go 2 units in the X direction. Got there and there. What is the location of those coordinates? Plus minus 2, 0. Very good. So what's the length of that transverse axis then? What's the length of the distance between them? 4. I'm going to draw my box. I went 2 units in the X direction, so I go how many in the Y? 5. And I make my box. And I draw my asymptotes. Is this hyperbola going to be really wide or really narrow? Really wide. Super wide. Okay. So, let's describe the equation for the asymptotes. Y equals. Very good. Plus or minus up 5 over 2. Up 5 over 2. Plus or minus 5 abs x. Foci. How many units? Which direction? Square 29 is like 5.4, something like that. Right and left. 5.4 units. Right and left direction. Now we're just getting an estimate so we can plot it. So that location would be plus or minus square root 29, 0. Now, Britton brought up a very good point earlier. Do you have to plot the foci in order to generate the graph? No. The only reason we plot them is because they're part of the definition. And they can be helpful to determine an equation. So let's say I didn't give you the equation, but I gave you some of this information. It might help you then understand how to actually, go from there. So, okay. What haven't I done yet? I haven't drawn a graph. This is the best part. Start the vertex. Follow my asymptotes. It's pretty cool. Very wide hyperbola. It's okay. What do you think? Bad? Not too bad? Easy? Same as ellipses just about, huh? Not too different. And this is the last stuff that you have to study for the test, really. Well, I mean, we're going to study more problems, but we're not going to talk about a new shape. You've seen all the shapes. Anything else before I erase it? Okay, so every year when I do these types of problems, I gave you one that was wider. Then I would want to give you one that was more narrow. But everybody kind of wants one that's vertical instead of horizontal. And so I always change the problem. So let's just change it. We'll do 9y squared minus 4x squared equals 36. That's what we'll do instead. What? Oh, cool. Awesome. I can't use that equation, though. What do I got to do? Divide by 36. Nine y squared over 36 reduces to? Y squared over 4. 4x squared over 36 squared over 9 equals 1. How do you know that this is vertical and not horizontal? X is negative, y is positive, so therefore it is a vertical hyperbola. I'm going to list all the characteristics. I'm going to start with direction. Direction, center, vertices, foci, length of transverse axis, asymptotes, A, B, and C. Okay. Direction, you already said up and down. Center, 0, 0. The only reason we're doing that is so that you know that the center could be different if we have a shifted hyperbola. Vertices. Ooh, how'd you get that? Very good. Caitlin goes through. She says A is going to be 2. B is going to be 3. C will be the root of 13. Time to make my shape. So we'll get back to Caitlin's point. Caitlin says that the vertices, she went 2 units in the y direction. Again, look, 4 is under y, so you go 2 units in the y direction. 2 units each direction. So we got plus or minus, 0, plus or minus 2. I'm now going to make my box. How many units do I go in the horizontal direction? 3. Got my box. Got my asymptotes. What's the length of the transverse axis? Distance between the 2 vertices. Yep, 4. Equation for the asymptotes. Y equals plus or minus something times x. What's the slope? 2/3. And now the foci. X direction or Y direction? Y direction because it's vertical. Square root of 13. That's like 3.6, so maybe like there, something like that. So that'll be 0 plus or minus the root of 13. And finally, we get to draw the curve. This was so difficult for me. It was so difficult. When I was doing this, I was doing an independent study on this topic between my freshman and sophomore year to try to get to pre-calc when I was a sophomore. And the book never showed any examples of vertical hyperbolas. I never knew it was a possibility. And so when I took my test, I made all of them horizontal. And I just got dinged on all of them. And I remember being so frustrated. I thought, well, the book never showed any examples. It talked about it, but do you think I read my math book? Well, no. Who reads a math textbook? Well, I did from now on after that. So anyway, I just remember that. In case you were wondering. Here you go. So, assignment. 1 through 4 are matching. And then 7 through 9 and 11 are drawing the graphs. 3 of them you can check in the back of the book to make sure you did it right. Please stay on top of your homework. Please, please, please. A lot of 45s out of 48s, 48s out of 48s on this test last year. There were a few 22 out of 48s. Generally, those people didn't keep up with their homework. So, but you got time. You got a little bit of time. But tonight, actually, I'm not watching a movie tonight. I'm watching Gold Rush. I love the show Gold Rush. I like watching that. And Bering Sea Gold. I like those. So you probably watch that while you do your homework. So, have a good day. Bye, Sid. Sid, we hope you had a great time watching the video. And Sini will bring treats for us on Monday. Sini, is that correct? Monday? You don't know. What do you know about bringing treats? Give us something definitive. Maybe on 3/4 birthdays. So if you are doing treats for pre-calc at all, just note something. 1, 2, 3, 4, 5, 6, 7, 8, 9, 14, 15, 16, 17, 18, 19. We have 19 in this class. That's it right now. And including me, we have 20. So if you make treats, don't worry about making for 20. Just make 19. We'll count Sini out until she finally brings her treats.